All right, we're going to cover Module 4, Homework 1. All right, so we're looking at 14 questions to address the concept of rationalizing the denominator, is what this is going to be doing. And it says where are radicals not allowed to be even if they are reduced? Well, it doesn't matter if they're even, odd, or anything in between. Radicals are not allowed to be in the denominator of a system. So that's why we rationalize denominators with radicals. So the answer here is just denominator. Okay. So when it says rationalize the denominator, now there's a couple of different ways of doing that. First, you can define it and then simplify, or then just approach it from the concept the way I'm going to do this one. So we have this one is question number 2. When we have 5, okay, radical 5, we can multiply it by radical 5 on both bottom and on top. So that way when we multiply this together, remember this is unique 1, all right? Being that that's a unique 1, we can go ahead and multiply the bottom and get 5, because any radical times itself is going to get out of the radical. And then we can go ahead and multiply this and get square root of 65. We can't reduce this. Remember, this 5 can't go into the 13 times. That's a mistake students make. Because the only thing that 5 can go into is a number that's on the outside, not on the inside of the radical system. So there's our answer to that. All right, pretty straightforward. All right, now, when you look at something like this, all right, so number 3, they're going to define it this time as 1. And then what you need to do is reinforce that they are separate radicals. So square root of 169 over square root of 5, just like this one was. And then the square root of 169 is 13 over radical 5. And then we go ahead and multiply both top and bottom by radical 5. And when we get that, we get 13 radical 5 over 5. 5 does not go into 13, and therefore that's our answer. All right? Now, same thing goes to the next one. When we have 100 over 3, we can separate that into 2 parts. Okay, that's radical 100 over radical 3, and then this is going to equal 10. And then radical 3, we're going to have to go ahead and multiply both top and bottom by radical 3. And that'll leave us with 10 radical 3 over 3. Again, 3 can't go in 10, so that's all we have for that. We're going to do in the deal. Okay? Pretty nice. All right? Now, when it comes down to variables, we're doing the same thing as we did before. Rather than writing it down, I'm just going to go take the paper right down and broken up values like this, split them up. And then the square root of 36 is 6. So now we're going to go ahead and multiply both top and bottom by radicals x. And that leaves us with 6 radical x over x. And that's our answer. So always think about in terms of whether or not you want to split them up or rejoin them. For example, here's a good one that we want to rejoin and watch this. When we have this, we see that the x's can simplify each other. So no longer do we have any x's. So you can rejoin the split radicals. And then after that, we can go ahead and re-split them up because we can't simplify 2 over or 15 over 2 any further. So then we go ahead and multiply both top and bottom by radical 2. Instead, no longer do we have any x's, so we don't have to worry about them. So we're going to go ahead and get square root of 30 over 2. And that's our answer. So that was a big strategy that we had to use. And see, that was a critical strategy. You want to go ahead and use these as tools in that. So now we have 81, C. Now, 81 and 7, we can't reduce that, so we're gonna just split them up. So we're gonna split it up, the 81 C over, and then it's square root of 7 B. Now, 81 we can take out of the radical, it's 9, radical C. And then we're gonna go ahead and multiply both top and bottom by 7 B, radical 7 B. And when we do that, the inside content of this radical come out as 7b, and then we're left with 7b times c, which we're not multiplying against 9 and then a radical c, we're just multiplying against the radical c, and we're going to get 7bc in the radical. And that's it. We're done. Now, I know that I make this look ridiculously easy when you understand the components and understand the parts and make those components, then you've got the idea of the strategy kind of implemented. Okay, so it's really important to break it down. Now, when I look at this, immediately I say, can I reduce my fraction? Can I eliminate any variables? And in that case, no. I'm just going to go ahead and take and break it up immediately. So I'm going to hit this. And then I'm going to go ahead and multiply both top and bottom by radical 14. Alright, so once I get that, I'm going to go ahead and do 11 times 14 is going to be 157, or not 157, 154, excuse me. And now I have x. I'm going to put that in the radical system, and it's going to give me 14. I'm done. Here's my answer. Alright, now, of course, you use calculators. I mean, I didn't know what 14 times 11 is right off the top of my head. I mean, I'm pretty good, but not that bad. So anyway, we go ahead and continue. So we look at this, and we want to simplify as much as possible. This one is challenging us to simplify the radical before rationalizing. So 12, for example, is 4 times 3, so that means 2 comes out, and then we have 1 x that comes out and 2 y's that come out. And what's left over is that 3, because 3 times 4 is 12, and then we have 1 x left over, and we have no y. So we have this. So I simplified that radical before multiplying these things. Now I go ahead and look at this, and I can see that this 2 goes into 14, right? 2 goes into 14 7 times. And then I'm going to go ahead and multiply both top and bottom by 3x, radical 3x. Multiply by 3x. So I broke it down before seeing what determinant do I need, or what value do I need to go ahead and multiply both top and bottom by in order to simplify. Alright, so I'm going to get 7 radical 3x all over x. Now, because the x, I have a second x, I'm going to have x squared. So I'm going to put the 3 on the outside because it's the coefficient. So I'll put it first. So 3, x squared, y squared. And there's our answer. Alright? Now, I choose to break it down first before multiplying both top and bottom by radical 12 x to the third, y to the fourth. That's going to get explosive values, and it's going to make it longer and harder. Okay? So the strategy is very straightforward when you're using this kind of concept of breaking it down and then rationalizing. All right, let's take a look at number 9 when we look at the same idea. So number 9. We take 13, leave it alone for a second. We have 8. 8 is 4 times 2. So we're going to take 4 out as 2. And then move 2 inside. And then we have an x. So we're going to multiply both top and bottom by 2x rather than by 8x. right? That's radical 2x, okay? So now when I go ahead and do this, this leaves me with the numerator 13 times radical 2x, and then I have this comes out of the radical system, so it's 2 times 2 is 4, and then I have that. That's my answer. I can't simplify it any further. All right? That is amazing. That's not even a perfect answer. That is not simplified. That is inappropriate. So that answer that I'm showing you, not good. I'll go ahead and slide that. This one needs to be. This one needs to be. This is inappropriate. Okay. That answer. Put this answer in, and it will be marked correct. By the way, I just don't like that answer here. I'll show you that it will make it where this is accepted. So 13 radical 2x. They won't. And then I add 4x. And even though, I mean, they will accept that answer because it's the correct answer, it's not the answer that they have displayed here. Okay? So that's kind of a little alarming, but I wanted to make sure that this was accepted by the system. Make sure. Now, let's take a look at number 10. We have 56 over 42. So here's 42. Now, remember what I told you before. You want to try to go ahead and divide 42 by perfect squares. So 42 divided by, for example, 4. It gives you 10.4. That's not working, right? So 42 divided by 6 gives you 7. And if we look at that, 42, then, if we break it down, then that's going to be basically then 3 times 2 or 2 times 3 times 7, which they're all prime numbers and they're not perfect squares in them. We can't do anything with them. Okay? We can't do anything with that. So I'm going to go ahead and just multiply then both top and bottom by radical 42. So I'm going to go ahead and get 56 radical 42 over 42. And then I'm going to simplify this. Okay? So now, with me, I mean, I'll show you something pretty cool. This calculator is that if I hit this, watch this. I mean, some of these don't like scratches. So I can put 56 over 42 and hit enter, and then immediately reduce it down. You're probably like, oh my God, how did I not know that? Right, this calculator is pretty awesome. All right, so now that's 4 radical 42 over 3. All right, and that's how that works. Again, it's ridiculous. They don't have it most reduced. How do they get an answer like that? Again, my answer is more perfect than that answer. 2 can go into 8 4 times, 2 goes into 6 3 times. 11. 1 over radical 18. It's okay. Now, when we look at radical 18, okay, we're going to go ahead and remember that this is really 9 times 2, which is 3. So let's go ahead and simplify that. It's going to be 3 radical 2 over 1. So we're going to multiply both top and bottom by radical 2. All right, and then that will leave us with radical 2 over 2 times 3 is 6, and that's what answer we're looking for. I mean, I'm giving you some really strong advice by breaking it down first. It'll make it so much easier when you simplify. Although it would work, it'll make it longer if you don't break it down. So Now, when we're looking at 80, right? 80 is immediately divisible by 8. You know that, but 8 is divisible by 4. So we're breaking this thing down, okay, into parts. Now, I'm going to do something with you. Prime factorization, you break it down by 2, it's going to give you 4, right? Or 40. You break it down by 2, it's going to give you 10. Break it down by 2, you're going to get 10. Break it down by 2, you're going to get 2 and 5, okay? So now, in order to come out of the house, you have to have pairs. So that's one pair right here and one pair here. So if you look at it then, it means that 80 is divisible by 16, right? So that's kind of a neat way of doing it. It's called prime factorization. So now we look at then, it's going to be 4 radical 5 is in the denominator. And then when we do that, we're going to multiply both top and bottom by radical 5. And then that's 5 times 4 is 20. And then radical 5 is up in the top. And there's an answer for that. So I kind of showed you now a new different strategy with prime factorization trees. All right, number 12. We have 1 over 5 radical 10. Radical 10 is 5 times 2. There's nothing really we can do with that. So what we do is multiply both top and bottom by radical 10. And then we're left with radical 10 over. And we're going to go ahead and get 10. 10 times 5 is 50. So that's the answer right there. And likewise, the same thing goes for the bottom there. It's going to be, I'm just going to do the answer. It's radical, not that I put here. It's going to be radical 15 because we can't simplify radical 15 any bit. So we're going to multiply both top and bottom by radical 15. It's going to be 15 times 3, which is 45. And there's our answer for that. So you can start doing these by mental processes. All right. Now, it says, what is the constant of this right here? Now, the constant is exactly the same value, except for it's going to have the opposite sign between them. So instead of being a plus sign, it's going to be a minus sign. If it was a negative sign, it would be a minus sign, it would be a plus sign for the constant. So the answer that we're looking for is 2 minus 5 radical 10. You do not take the opposite of the 2. You only take and put the minus sign in the place of the plus sign. And that's your answer. That's a conjugate. So what's the conjugate of this one? Is simply then opposite of the minus sign is going to be a plus sign. So it's going to be 2 plus 10 and then radical 6. So that's the answer. So it becomes a plus sign. And that's it. All right. So that concludes this video.